We hear about AI and machine learning everywhere. It feels so complex, right? But what's really going on under the hood? Well, today we're going to pull back the curtain on one of the most fundamental ideas that powers the whole thing. And trust me, it's way less complicated than you think. It all starts with a really, really simple question we all ask. Think about it. You ask this all the time. You check your weather app, maybe you glance outside at the clouds, and then you make a call. You're dealing with uncertainty. You don't know for sure, but you're trying to figure out the chances. And this idea, it's not just about the weather. Not by a long shot. In the world of tech and business, this exact same question about uncertainty pops up constantly. Trying to predict what a person might do next, that's one of the biggest puzzles that companies and machine learning are trying to solve. So how do we get a handle on all these maybes? Well, it turns out there's a mathematical way to talk about all this uncertainty. And if you can wrap your head around it, you basically unlock the core logic of how machine learning thinks. And that language is probability. That's it. It's just a tool for measuring how likely something is to happen. It's not some crystal ball that gives you a definite yes or no. Nope. It's something way more useful. It's a measure of confidence. And we measure it on this super simple scale, from 0 to 1. If the probability is 0, forget about it. It's impossible. If it's 1, it's a sure thing, guaranteed. Now here's what's so cool. Almost everything in the real world, from flipping a coin to predicting what you'll buy next, lives somewhere in the middle, between those two extremes. So this scale, this 0 to 1, it's not just some concept for us humans. It's literally the native language that machine learning models used to tell us what they've learned about the world. This quote right here, it just nails it. The whole point of AI isn't to be this perfect, all-knowing oracle. It's to look at all the messy, incomplete data we feed it and make the absolute best guess it can, while also being really honest about how uncertain it is. And this shows you exactly how it talks. A machine learning model doesn't just say, that's spam. It says, based on everything I've seen before, there's about a 92% chance this is spam. See, it speaks in likelihoods. And that gives us a much richer, way more useful picture than a simple yes or no. Okay, so that's the big question, isn't it? Where do these numbers, this 92%, this 70%, where do they even come from? How does a machine learn how to calculate the odds? The answer is actually pretty intuitive. It learns from experience. A machine learning model goes through this process called training, where it just churns through massive amounts of old data. It figures out probabilities just by seeing how often things happen in the past. It's basically a pattern-finding machine on steroids. Let's make this super simple. Imagine a model looks at 100 emails. If it sees that 80 of them ended up being spam, it learns a basic rule. The probability of a new email being spam is around 80% or 0.8. It's learning right from the history of the data. But the story definitely doesn't stop there. This is where it gets really, really smart. What happens when a new piece of information enters the picture? What if we know something specific about this email, like it has the word free in the subject line? Does that change the odds? Oh, you bet it does. This is a huge concept called conditional probability. What's the chance of A, given that B has already happened? Or for us, what's the probability of spam, given that the email contains the word free? A model's predictions get way more accurate as it gets more info, what we call features. Features are just those specific little details, like the words in an email, who sent it, even the time of day. The more clues a model has, the better it can adjust its probability. And that brings us to what might be the single most important takeaway from this whole explainer. It's a fundamental shift in how you have to think about AI and the predictions it makes. The old way of thinking, let's call it the certainty mindset, demands a black and white answer. This is spam. But the new way, the probability mindset, understands the output for what it really is. There's a 95% probability this is spam. It's not a statement of fact. It's a statement of confidence based on the evidence. So why is that so much more useful? Because it lets the model be honest about its own limits. It tells us how sure it is, and that lets us make way smarter decisions. For example, maybe we auto-delete anything with a 99% spam score, but we flag emails with a 75% score for a human to take a quick look. And once you start thinking in probabilities, you see it, oh my gosh, it is everywhere. The videos that get recommended to you, that's the probability you'll like them. Your credit score, the probability you'll pay back a loan. Even the very next word a chatbot suggests is just based on the probability of what makes the most sense in that sentence. It's all running on this one powerful engine. So in the end, if you remember one thing, remember this. A machine learning prediction is never the absolute truth. It's just the story that the data, with all its patterns and all its flaws, is able to tell. And by using the language of probability, AI can tell that story with more honesty and more nuance than ever before. Which makes you wonder, right? The real question is, how good is the data that's telling the story in the first place?